as Dave and I were driving down here yesterday, he said, hey, why don't you do the talk? It's like, so I had one day notice and put this deck together this morning, but actually it turned out to be a good thing because I had no idea that agents were going to be a topic of discussion. So with Jim Senior bringing it up yesterday and having a little discussion, it gave me a whole topic to talk about. So we'll be talking about today agent-oriented architecture for cross-process governance. So a little about me. I've been at EnterpriseWeb now since the beginning of the year. And before that, I was at ZapThink for 12 years. And I know a number of you are familiar with ZapThink. We were an industry analyst firm and then an advisory firm focusing primarily on service-oriented architecture, enterprise architecture broadly speaking. And we ran a 4-day SOA course that I would run all around the world. And there was a problem with that SOA course, and that is that I'd be talking about service-oriented architecture to architects around the world, basically laying out how it was supposed to be done, but I realized that really very few of them would ever be able to do that, because SOA always left something lacking. There was a great story about services being loosely coupled interfaces, and the goal of those services was to build compositions that implemented flexible processes. But it's interesting that, yes, agents were something that was mentioned yesterday, but there are two things that I have not heard once during this whole 2 days. One is BPL, Business Process Execution Language. Nobody has mentioned that, right? That was a web service orchestration language that fell flat, right? Somebody's saying, no, no. A lot of talk about BPMN, but not BPL, and that was one of the problems with the web services-based approach to SOA. And of course, the other phrase that nobody's ever said is web services. Nobody's talking about web services, and nobody here is saying that BPMN is a tool for composing web services. So we have this problem with SOA that it never lived up to its promise in terms of business process or in terms of enterprise integration, right? We weren't able to solve the problems we were looking to solve. So EnterpriseWeb is a company that I've been advising for a number of years, and they actually sponsored our poster. And you can pick up a copy of ZapThink's most recent poster on the table there on your way out, so feel free to get that. And when it came time to make a move and leave ZapThink after 12 years, I chose EnterpriseWeb because they were really the only vendor I'd ever run into who had technology that could help organizations solve the problem that SOA was meant to solve, but never was able to actually go all the way there. The problem of how to build dynamic integrations of capabilities in a way that provides business agility across the organization. So that's essentially why I joined EnterpriseWeb. I wrote the book Agile Architecture Revolution. It's been out for about a year, and I laid out a story for Agile architecture, which again was the story of what SOA was meant to be, but never really was. And now we have a technology that is able to support the vision that I laid out in the book. So it's all part of the story. So what is EnterpriseWeb? Well, it's hard to describe. And that's one of the challenges that we have. So one way of putting it is we're a dynamic platform for building agile systems. But that still is only a very concise way of describing what we do, because you can build systems, you can run them, and you can integrate them all dynamically in real time. So it's more than just building systems, but that's fundamentally what we enable organizations to do. So yes, we help implement what we like to call an agent-oriented architecture. And this is a new concept for us. We're just trying to put the fine point of what we mean by agent-oriented architecture. But from my background as an enterprise architecture thought leader, I really wanted to place this into the context of enterprise architecture, a style of enterprise architecture that drives business agility by leveraging policy-based, data-driven, intelligent agents. So that's the agent part of the story, the technology enabler of this architectural style. And these agents provide maximum affordance in real time. So an affordance is essentially something that technology or something that technology or an environment enables actors to do. So instead of a software that has a capability, we offer affordances, which enables people to do things, and we offer maximum affordance. So we offer the ability for people to do many, many, many different things with our technology. And that makes it very hard for us to describe what it's really all about. So how does this agent work? Well, this agent essentially customizes system interactions by dynamically transforming abstract models into concrete resources. So the abstract model essentially is a representation of the capabilities that you're looking to achieve, and then the agent dynamically in real time is able to actually follow those instructions, obtain the metadata, data, code, rules, process logic, whatever it needs in order to complete the interaction for every interaction in real time. So what we named the agent, we call him Smart Alex. Little personification there, give him a little character. And Smart Alex is essentially an intelligent agent that organizes the right content, the right information, the right metadata for the right person, for the right interaction in real time. So there was a discussion yesterday afternoon about what an agent was. And of course, agents have been around for years in different contexts. We like saying Smart Alex is Siri for the enterprise because people are familiar with Siri as an enterprise agent now. But of course, agents have been all with us for years. But one of the things that distinguishes our agent is that it's essentially underspecified. It doesn't know what it needs to do until it gets a message. And then it goes and fetches everything it needs in order to process that interaction. So you don't have to code the agent, and all the agents are exactly the same. So we have one agent that is distributable. So it can distribute itself and make as many copies of itself as it needs, so it's fully scalable. But it runs in an isolated thread and is very lightweight. So a single virtual machine or a server can run thousands of these things. And if it needs to run more, it can call for more and essentially provision as many instances as it needs to respond to as many requests that come through. So here's essentially how it works and really why we're talking here at a BPM conference, because a central role of the agent is to support flexible business processes. So, but these are flexible processes where you don't necessarily need to know what the process is going to be like. You have a goal, right, and it's essentially a set of activities that lead to a goal, right, as a few of the people have said over the last couple of days, but you don't necessarily know ahead of time what the sequence of steps are. It might be different for different people. It may have some sort of change in the logic as you go. So the first step, right, is you have an understanding of the business goal, and a system event takes place. And it could be a user taking an action or some sort of server event or any kind of system event. And that becomes a request that the agent now, it wakes up and says, well, I got to deal with this request. So this agent interface is a uniform interface across the entire system, where the system could be distributed, could be multiple applications running in the cloud and on-premise. Well, we have now this single interface, right? Every request goes to the agent wakes up and processes the request. So it's very lightweight and very simple from the perspective of what you need to do in order to interact with the agent. So once the agent wakes up, it interprets the model, which serves essentially as the program the agent is going to follow, but it's lightweight and it's declaratively constructed. And I don't have time to go much in depth in the model, but it interprets the model and everything else it needs to interpret. Any semantic content, any metadata, any rules, any policies, any data, any code that it may need to find anywhere in the entire distributed system. So it evaluates the request against these policies, rules, and business context. It processes them, and it does so recursively by following hyperlinks, referencing URIs as needed. So if it doesn't have the information it needs, it knows how to find it, and it continues to do this until it's able to respond to each request, for each request, dynamically in real time, right? And then it can also make recommendations in terms of the next best actions. So you don't necessarily know ahead of time what the next step is going to be, so the agent can make those recommendations and say, well, if you're trying to achieve this goal, maybe you should do that, or maybe you should do that, something else, and it can make those recommendations to the user or to the actor. And then while it goes, it provides an auditable history of activity. So it has built-in change management, built-in version control, and a built-in auditability, so it supports flexible governance. And that's a key part of the story I wanted to talk about today, is the governance part of the story as well. So this is essentially the heartbeat of our entire platform, right? Every request, agent wakes up, right? interprets the model and semantics, evaluates rules and other metadata, resolves all issues recursively by following links to obtain additional information that it may need, makes recommendations for best actions, and delivers custom interface and payload, right, custom to whatever the need is. And if something changes from one request to the next, your metadata change, your data format changes, your interface changes, it doesn't matter because the agent fetches the information dynamically in real time. It caches in a smart way, but it realizes that for every request, it needs to fetch current versions of all the information it needs to process. So all this takes place in real time. So we essentially have this cycle, right? It repeats this cycle as many times as it needs to respond to each request, and each individual copy of the agent does this for each individual request, following all instructions, resolving all issues with consistent semantics and resolves the business context as well. So this is one of the important parts of the story, is how it deals with constraint satisfaction. Right? You may have a variety of different policies or rules or other issues that apply to different parts of your system, and the agent is able to resolve those issues as a single set. So it essentially solves for the one solution that is the optimal solution for that particular interaction. Even if there are a lot of competing policies or some sort of resource constraint, people fighting over the last seat on an airplane, whatever the issue is, it's able to resolve those to the best result for each request in real time. And that's what the demo will show as well. So when we talk about these flexible models, we like to use the word cloudlets. Cloudlet is essentially this abstraction of the capabilities that you can assemble in order to build capabilities using our platform. So it takes care of the technical details, security and identity. Security is now straightforward because all security policies are now handled in a consistent, uniform, universal way. A compliance monitoring, key part of the story, and you'll see some of that in the demo, as well as IT governance, system controls are all part of the story, and context-sensitive processes that can be sensitive to differences in information, differences in individuals, differences in regions. Whatever the business context is, the agent is sensitive to those. And we can deliver personalized, real-time personalization and customization as a key part of the capabilities of the platform. So if you put it all together, this is sort of how it all ends up looking, right? We have the agent, distributable agents that process the abstract models or cloudlets. We have a metadata fabric that covers everything the system does. So we have data and code in little boxes, which are the resource pool that could be running anywhere, in cloud, on-premise, legacy apps, other apps, who knows? It could be anywhere and everywhere. And then for some examples, we have a variety of connectors to various backend systems. But even though the resource pool looks like it has different kinds of things, data, code, APIs, web services, whatever, the agent treats them all the same. Data is the same as code, is the same as metadata, is the same as web services, APIs, RESTful APIs. They're all treated the same way. So the agent is able to provide a uniform interface to the entire system for every interaction. So one of the key benefits of this, and this is really the important story for this audience, is the ability to provide cross-process governance. So let's say that you have a large organization with different offices in different countries, and you have different processes in different countries, and you're trying to coordinate those processes in the context of a heavily regulated environment, where you have all of these complex regulations that may apply differently in different countries. Well, that can be an enormously difficult task because you have to resolve the constraint satisfaction for every interaction across the entire organization, even though you have different applications in each country and different people and different processes. Well, each individual process can be governed as the agent interacts, as people call the agent and deal with interactions. But the agent also treats the entire enterprise as a single system and is able to resolve constraints across the organization. So, and this is something that we actually have working in our clients, some of whom are in the research industry, right? Have tens of thousands of people doing human trials, animal trials, very heavily regulated. We're supporting their complex research processes, applying for grants, getting the money, doing the research, doing all the paperwork, and it's a heavily regulated business, and there's a lot of interacting constraints, whether it's conflicts of interest or regulations that apply to the research processes themselves, or all of the rules about how the money has to be handled. And we help them essentially resolve all of those conflicting issues dynamically for every request in real time. So, but are we a BPM tool? Well, not really. Fundamentally, EnterpriseWeb is a flexible platform for building tools. So you could build a BPM tool, and a lot of our customers use it that way. You could build better integration technology, build a better ESB. You could build better Hadoop with us. You could build an Internet of Things agent, put the agent on devices and build a more secure Internet of Things. There's no end to the number of possibilities. And this gives us a bit of a Swiss Army knife problem. It's like, we can solve any problem, that's great. But it also underscores the power and capability of our platform. So next up is the demo. So to help us, we have Bill Malik. Bill, can you hear us? See if the technology works.
Yes, I can.
Ooh, how about that?
Can you guys hear me okay over there?
Yes, they can hear you. And Bill is calling in from Waterloo, Ontario, Canada. He's our chief systems architect and co-founder. And so it's all yours. Take control and go from here.
All right, so for the agenda right now, I'm going to go through a demo, and what I'm going to do is I'm going to jump into an environment that's already running and has cases and processes. And as Jason was talking about, he was saying that we want to look at cross-app governance and how, in this case, I'm going to take you through a scenario where I'm going to build a new app basically from scratch. I included a couple of objects already just for the sake of time. But effectively, what I'm going to do is go from scratch, and I'm going to take the idea of leveraging what the system does just, if you want, for free. So taking things like a declarative description of effectively a conflict of interest process, and I'm going to show how the system leverages resources in both building and executing that actual application. So how it takes advantage of the affordances that the agent provides you. And then I'll show how non-disruptively is actually weaved into the cases. So we'll drive into a case that someone was working on and see effectively how the system has merged this new app with some existing ones. So with that said, I'm going to jump into the system here. I'm going to log in. I'll spend about a minute just giving you a bit of an orientation. Effectively, I've jumped into this environment, and it knows who I am and everything about me. I have things like a full functioning mail system that I can grab my mail out of, so I can find out my new messages and all that kind of good stuff. It can be connected to any kind of messaging service that you might want, or social app, what have you. It'll pull from any source that you feel like. You can look around at things like, I'm going to have a profile that's inside the system. And actually, what's going to be important here is the idea that my profile can include things that I might decide to effectively, in this case, I might be submitting, right? I'm actually going to be saying that I have a potential conflict of interest with a few people in the system. Now, if you think about it, we have, I think in this environment, we have thousands of people. What the system's going to do in my app, so just to set it up, is I want it to be able to look across all these potential conflicts of interest, and I want it to do that recursive walk that Jason was talking about and be able to figure out, effectively, if I define a policy, where that policy applies. So all the cases that are currently running in the system, I want to weave through all of those and basically come up with any of the places where my new policy actually takes effect, and then I'd like to be able to examine all the connected resources. Effectively, I'd like to be able to see the whole story of what's behind this app based on things like conflicts of interest that people are declaring in the actual UI. So we'll look at a case itself in a little while, but basically what I want to do here is on my dashboard, I've got this conflict of interest app. I'm going to pop into it, so I'm going to view the object if you want. I'm looking at the actual app, and I'm going to declaratively go through the construction of this thing. So I can, of course, give it whatever kind of name I want, and all of the kinds of things you'd expect from a case are actually here as well, because an app of its own really is a case. It's something with a life cycle, something you want to provide audit against and potentially some processes on. So we've wrapped it in a case. So the conflict of interest app here has some of those things like log tables and so on you'd expect to find. Now what I want to do though is step through the specific things of this application. So I'm going to really just sort of, if you want, walk left to right through here. I will just pop through the particular tabs for a second. I'm just going to say, there's application details that are going to be described. There's going to be some linked objects, so resources in the system that I want to use when I'm assembling this application. There might be some workflows. We'll add a workflow here. And there might be some instances where this app's actually been launched. You can see right now we haven't filled anything in yet. We haven't created anything effectively. So there are no instances that we can look through. But when we do, this will be a container for not only the construction, but also sort of the full reporting of the instances of this app. So I'm going to start by walking through the context. And I'm not going to try to make you an expert in any of this stuff, but I'm just going to effectively walk through what the system's going to guide me toward, which is, I'm going to define a primary relationship. Is this app just standing alone? Is it related to other applications or objects? As I start to walk, the system, of course, that idea of the agent is almost at play here, where it's not only like next best actions, but it's also showing you things like any applicable choices. It's just trying to make it really easy for me to wire in this new app that I'm going to create. So we only have two other apps that are sitting inside this app. This environment right now. We have cases, ad hoc cases, and some proposals that are a more structured app. I'm going to connect it to a case. And then it's going to start to walk out effectively the logic that I want for linking this thing. Now, do I want to be creating, and right here, do I want to link to all cases? So do I actually want to just flat out introduce what would be a cross-cutting concern against every one of these cases that's in the system? Do I want to manually select them from a list? And you're going to see how these things can play out a little bit more in a minute. But the one that's going to be interesting for us is that I'm going to just use relationships. So I'm going to use the relationship builder here to actually just specify something really easy for me that'll power effectively the rest of the app. So I could go further always, but right here I'm going to show you it sets up with a linked object that is related to basically my context. Do I want to see something that's linked to the case? Do I want to see any of the collections of objects that can go into the case? So I want to say a person on the case. I'm going to see the types of link relationships that are available in the system. They're all surfaced for me to make easy, so you can read this in human way. So I can say, when a person has a relationship with another person on the case. So I'm going through this relatively straightforward, but you can effectively read this in English that's really what a conflict of interest is. It's someone with a declared relationship to another in the context of my case, and I'm going to give this some kind of a title so that it can render that for me. So I'm going to call it a potential conflict of interest when I start looking at any graphs or anything else inside the system. So from a surface level, that's relatively easy to set up. But now the great thing is that as I start looking at things like the instances that are applied, I'm actually seeing already the system's sorted through all of the different cases that are in there, and it's risen for me 4 that meet that criteria. Now, it'll be a little bit more exciting when we actually start looking at things like, if I look at the actual objects that I've created that I'm going to put into play. So this, you can walk through, effectively you can walk through registries of any of these kinds of components to reuse one of those cloudlets that were described by Jason earlier. So I can pull out a function that someone's built for me to work with another system. I can pull out something that might even be a system function that would say, maintain parameters on running cases, do maintenance on the data. And in this case, what we're going to actually be doing is we're going to be enforcing a policy for an additional, we're going to effectively attach a conflict declaration form to each one of these apps, and we might throw a little alert as part of the process. But when I'm looking at these components now, this is actually the neat thing. I can drill into one of these components, and I can show how it's connected in the system. So I see from the surface right now, it's connected to this conflict of interest app. It's connected to Bill Malik. That's fine. But when I look at the graph, what I'm actually seeing here, this is actually, I'll go into some more depth, and I'll spend some time here on the graph. But this graph is actually a graph of, and I can zoom in on it however I want. So let's zoom in on it a little bit better. I can walk from what is effectively over here, the form itself, and I can see its relationship. So it was created by Bill Malik, as we know. It's linked to this conflict of interest app. But now what I can do is I can start looking at where it is in the context of the system. And by playing with parameters on the other, by playing with the parameters that are making up this case, these graphs are going to be real time and are going to be adjusted. So I'm actually seeing that there's going to be an instance of this form connected to something called the exceptional drug study. And when I start looking through it, it's going to tell me what that potential conflict of interest is. So I'm seeing the intersection of those people all the things that they
get
declared in their
30
profiles
minutes.
and the fact that they were on this case actually are visualized for me here. And it's even interesting in that if I start looking at these, I might see different relationships too. This is the one I'll start looking at in a bit, will be one related to Dave and so on. But there's one here even with, I think, okay, so 3 people are going to be related in this case. And if you had cross relationships, so someone from one of these cases was going to be related to someone in another, that would even show up here in the graph. So this becomes something that's present for every app that every resource that you're looking at in the system. And they're always real-time generated. They give me that full story of behind the scenes, what the system, when we talk about the agent recursively walking, this is the kind of thing that's walking in the sub-second speed to be able to put together an app like this. So what I'm going to do next is I'm actually going to build a workflow out of this. So I'm going to pop into the next form, and I'm just going to put together a simple workflow, and I'm going to call it my conflict process. And what the system will let me do now is actually walk through we work with asymmetric workflows. So I can start with a process, and I can set when it will start. I can set up as many tasks as I might want. And I'm going to create an automated one. I'm going to say send an alert to start. I'll walk through creating a system task. It's going to prompt me with any of the functions that are attached. I have a little alert for potential COI. I'll just add that. And what it's doing now is it's building for me graphically down here what that process is going to look like. And it's really an asymmetric workflow in that I can add as many different branches to this as I want. I'm actually, in a way, I'm simulating the workflow right here in front of you. So as I click on the send alert task, now what I'm doing is I'm actually in the task, and I can start defining next actions for it. So I can go in and I can say that I'm going to have a new thing, and I'm going to say this is going to be distribute form. It's going to be a human task. Now, even when I'm specifying the content of the task, the system's aware of things like the fact that I might want to populate this from case context. I don't know who this is going to be. It's going to differ based on the case. I don't want to go into any long description of it. I just like to be able to attach the fact that it's going to figure out who to send this to based on the relationships that are there. I'm going to say fill in the COI. Please see attached form. And again, it's giving me those objects that I've already linked in here. So the forms, the form that I showed in that last view. And now what I can do is I could actually add, at this point, I could start walking. I could add another branch at this point, and I can add, again, same kind of thing with a nice little declarative policy as far as when I want to branch. In this case, I really just want a straightforward process to show you guys sort of the capability being weaved in. And I'll just say review at the end. And I'll make it come back to me as the owner of this case. So straightforward, I now have a process in the system. What I'd actually like to do is, I'd like to start that process. So I've done that. I now have instances in the system that have the state that matches up with the front. I've created my process now, and in that couple of minutes, I've actually had it weaved into the system across any of the apps it applies to. So let's go in as Dave at this point. One of the people who was involved in one of the cases. So we're going to pop in as Dave Dugal. We'll see a few things. He's going to get a mail notification over here telling him he has some tasks and other messages in his queue. He actually has this alert that came to him as a result of the fact that there's a possible conflict of interest. He's got a piece of work product that's been sent to him, defined in that little workflow, basically telling him to see the attached form. It could be, modify the case, whatever that chunk would be, has actually been automatically applied against the case. He can go in and take a look and start filling in whatever information is actually required by that form. And then, of course, on the other side, he can look at the case itself that it was applied against. And this is where it gets really interesting, is that he pops into the case, and it's a pretty rich case on its own. It has ideas of custom case variables that are going to be normalized across other people's cases. It has things like a rich set of people that have been set up for this case. That was where it mined the relationship between him and Archita. It has messages that might have been sent. And when you start looking at things like the workflow, here's where you see that that workflow chunk has actually been inserted right into the process here. So it's become part of the running case, non-disruptive. And if you look at things like the linked objects, now that new instance of the form is actually attached here. That conflict form, I can get to it right away. I can see things like its connections. And what I'll see with its connections is I have a little bit of a different list now. In this case, it's actually connected to that conflict of interest. It's connected to the existing case. It's connected to the person who actually built the conflict of interest form and the person who it's applied to here. So you're seeing a number of things here right in place. And then even to the point of things like a case log that's going to show me who's done what, who's touched this case when. And I can trace through it and see that there's basically been an insertion made by the system. So that was a pretty rapid example, but hopefully it shows you guys a little bit of the, if you want, the flexibility and the speed at which you're able to accomplish things using this agent-based technology.
Thank you, Bill. Ready for questions?
Thank you. Let's thank our presenter.